All right, so today we're going to be trying to find things other than A and Y. We're going to try to find B. We're going to find R. We're going to try to find T, right? So there are a couple skills in the middle of the problem that are going to come up, so we got to make sure that we're solid on how to do those skills, right? So that's what the warm-up is intending to do. All right, so we're solving for x here, and x is inside parentheses being raised to a power. This is a little throwback. We would isolate the power and then undo the power. Well, is it isolated? No. Is the thing being raised to the eighth by itself? Yes. So now it's time to undo the power. So if you're raising something to the eighth, the opposite of that is 1 over 8. So I'm going to raise this to the 1/8 and raise this to the 1/8. Okay? This unbreaks the 8 and then 1 and the 1/8, they undo. So I end up with this 1 plus x. And then on the other side, I have 157 to the 1/8. I put that in my calculator, and I get 1.88. We'll say 1.88. Okay, now really quick, in your calculator, do not put this, 157 caret 1 divided by 8. What am I missing? Yes, the parentheses. You will get a very different answer if you don't say to the 1/8. Without the parentheses, it thinks you're taking it to the 1, enter, divide by 8. That's not the same thing. Take it to the 1/8. Okay? Now, you shouldn't.
I got 8,967.
Well, you have a graphing calculator on the scientific ones. All right, so if that is true, we still haven't finished our question because we want to know what x is. So what do we do? Minus 1 minus 1. All right, x equals, what is 1.88 minus 1? 0.88. Okay, that will come up in problems, okay? So you got to make sure you can do that. This next one is similar, but there's a little extra step at the end. If I have something being raised to the 5th, then I need to undo that. I will raise it to the 1/5. And that to the 1/5 as well. And I get 1 minus x equals, and what is 92 to the 1/5?
9.5. Oh, I did 0.2.
2.47. Use your parentheses. Okay. Now, I want to get x by itself, and this is, for some reason, a little tricky for students because the x isn't in the front, so it's like, well, what do we do? But think about it this way. What is on the same side as the x? A positive 1, right? And if I want to move a positive 1, I do a minus 1. Minus 1. So I end up with negative x equals 1.47.
Then we divide by
Negative. Yeah, so you divide by negative 1.
So it's negative 1.
Yep. X equals 1.47. Negative 1.47, sorry. Okay? So that might happen. Okay, so those two problems were one type of situation you'll run into today. Here's another. Okay, I haven't really taught you what to do with this yet, but we do know that when we have something with an x, we usually want to get it by itself. So if I wanted to get, for instance, this part by itself, what would I need to get rid of?
5 divided by 5.
Yeah, I would have to divide by 5. So I'm going to divide by 5 and divide by 5. I get 3 to the x, and then on this side I get?
19,683.
Okay, so here's the problem here. I haven't taught you about logs yet. So you don't actually have a step or a process to solve this. But you do know what the solution to an equation is. A solution is something that makes it true. So really all you need to do is find the x that makes that true. How could you do it? Plug in some numbers until you find one that makes it true, right? That's the only thing we have in our bag at this point. So yeah, maybe you're like, pick up your calculator and you're like, I don't know, 3 to the 8th. And it's not high enough. So you go 3 to the 9th. And you're like, oh, there it is. Because you would find out that 3 to the 9th equals 19,683. And I'll keep them perfect for now until I teach you the real way. But so that means if that's true, well, then that x must be 9. Okay? And I would give you a problem where it wouldn't work out yet because I haven't taught you how to really solve in for that missing exponent. Okay? Same kind of thing over here. I need to get this part by itself. So I'm going to divide by 9, this massive number, and I get 823,548 equals 43. Yeah, that's what I said. Equals 7 to the x. All right, so again, I know this is a huge number, so I'm probably not going to start at 2. But I'll go like 7 to the something big, and then I'll keep going up until I get it. And when I do that, I find out that 7 to the 7th is exactly the 823. Good job. Good instincts. So, ready for therefore? Therefore, x equals 7. Okay? Okay.
Wait, those 3 dots are therefore?
Yes, I love using them.
What is that for?
Therefore.
Those are way therefore.
Therefore. What is that for? Therefore. Therefore is that. That's for therefore. Do you know what I mean by therefore? It means because of that, boom. Like if this is true, then that's true. Therefore. No, it's like a grammar. It's like this is true, therefore that is true.
Like as if you're writing a sentence.
Yeah, exactly.
With math.
With cool symbols. Okay, so this is what we're going to do. I'm going to go through 2 problems with you that are like yesterday, except the pieces that are missing are different. So the solving that will have to happen is different. Then I'm going to set you up on the backside, and you're going to show me that you know how to do everything from this week. Okay? Questions? Okay. All right. So for each situation, we're going to write an exponential model, meaning that y equals ab to the x, and then use our equation to answer a question. So you always want to be doing that. You're not always going to have these boxes on like a quiz or a test. You want to make your own, okay? If you don't know what you're missing. Okay. So a biologist, once again, we have bacteria. Studying this bacteria at time 0 hours.
0. That's just 1.
What does that mean?
It's just 1.
It's our start. Like if 0 hours have gone by, it is the beginning. So if you see that, that means start. He puts 100 bacteria in a petri dish. One of those little circle dishes. And then 6 hours later, he measures 450 bacteria. Assuming the growth is exponential, what is the growth rate as a percent of the bacteria? Round to 2 decimal places. Okay, so let's think about what we know here. Okay, do we know the end value? Do we know how much we end up with? What is that? 450. Do we know what we started with? 100. Do we know the percent change? No. Do we know the time that went by? 6. Okay, now because they asked for the percent change, not the multiplier, the percent change, we're dealing with R here. It's not even asking for B, it's asking for our R. Sometimes they ask for one, sometimes they ask for the other, right? When we're dealing with R, we use this formula. Y equals A times 1 plus or minus R to the X, okay? Now, we're going to plug in our pieces, but we also have to make a decision about that plus or minus. Is this going up or down? Up. So it's going to be plus. So we'll have 1 plus r to the x. But we actually know some other pieces here. What's our y? 450. And what's our a? 100. And what's our x? 6. Okay. So this is the problem we need to solve. Okay? We need to use this to find our r. It's going to become similar to our warm-up. Okay? What is being raised to a power here? This part, right? So that needs to be isolated. So what needs to go away? And how do we make it go away? Divide by 100. And when I do that, on the left side, I end up with 4.5. And on the right side, I have 1 plus r to the 6. Okay, how do I get it to not be to the 6? How do I undo the being to the 6? Do the 1/6, yep. So I raise this to the 1/6, and I raise this to the 1/6. The 6 and the 1/6 cancel, and I just have 1 plus r, right? 4.5 to the 1/6. 1.28. Okay. Now, I want to know r, so I still need to minus 1 from both sides. Minus 1, minus 1. And it turns out that r equals 0.28. So let's answer the question. They asked, what percent is this growing by? 28%. So it's going up by 28%. Okay? That's one type of scenario where you need to solve for your r by doing some raising to the 1 something, 1 over something. Okay? Another type of scenario, which will look like the other warm-up problems. And this problem's a little gross. Okay. Unless you love rats. I don't know. You do love rats? Okay, well, if you think they're cute, you're going to love this because there's going to be a lot of them. Okay? If there are 50 rats in a New York deli, you're in an average New York deli.
Okay, that part, I don't know about that.
I know, that's a little bit of exaggeration. But if you're in New York, you will see 50 rats by the time you move away. Okay, there are 50 rats in a New York deli, and the number of rats increases by 100% every week. We're in trouble. We're going to have to call the health inspector pretty soon. How long until the deli has 12,800 rats? Okay. No. Not quite. Not quite. So 100%, 50. That would be if it was linear. It's not. It's exponential. Okay? Now, what's our n value here? 12,800 what? Rats. What's our starting value? 50 rats. Now, what's our percent change, meaning our r? 100% as a decimal would be 1, right? Just 1. So our b value is, we'll hold off on that. Our r is 1. Hold on. Okay, what about our time?
1.1.
Hold on. Hold that thought. What's our time? Unknown. When they say how long, or they say when, and they say something about time, that will be the unknown, right? So we don't know this. This will be left. Now, our equation is y equals a times 1 plus or minus r to the x. So let's plug in what we got. Okay. Do we know y?
Yes.
What is it?
12,000.
12,800 what? Rats. Remember, picture this while you're doing it. It'll help you remember. All right. What's our starting value?
50 rats.
50 rats. And then, are we going to do 1 plus r or 1 minus r? 1 plus, what was our r? What was our r?
1.
R. 1. To the,
We don't know.
we don't know, x. Okay, so what is 1 plus 1? 2. So that actually turns out to be our b value. Does that make sense? That's what we would multiply by. Okay, so it's 12,800 equals 50 times 2 to the x. Okay, similar to the other warm-ups, right? We need to solve for that x, and it's in an exponent, so we kind of need to get the 2 to the x by itself. So what do I do to get 2 to the x by itself? Divide by 50. And I end up with 256 equals 2 to the x. Now this is where we need to think outside the box of rats and ask ourselves, well, I don't know quite how to do this, but I know I need to find an x that makes that true. So I'm just going to try some numbers and see 2 to the what is 256? 8, right? So if 2 to the 8th is 256, then x must equal 8, and our answer to the question is
Hours.
rats. No,
Hours.
8 weeks.
8 weeks. No.
8 weeks. Our answer to the question is rats. All right, cool. All right, so now you've seen every type of problem, finding all 4 of the pieces. Now, what 4 pieces? Well, go to the back. I'll show you what I mean. All right, so on the back, I've given you every answer. I have given you the answer to all 4, right? And then I'm going to talk to you about taking some away. Okay, so remember, y equals ab to the x, right? Well, that's 1, 2, 3, 4 things you might find. Sometimes b is a 1 plus minus r, but those are the things you would find, right? I'm giving you all 4 of them in this scenario. And then in each corner, I'll take away 1. And you have to prove to yourself you could find it. And here's your answer key right in the middle. Okay? So in the middle, you get all 4. In each corner, I take away 1 at a time. You solve for it, and then you can find it in the middle. So prove to yourself that you did it right. Okay? So I'll show you what I mean. Look at this. We got all the pieces, right? Our n value. Well, 16 bacteria cells were collected and found to double in quantity each day. After 10 days, there were 16,384 bacteria cells. Any of those sound like an n value? 16,384. All right, your starting value. What was the starting value?
It was 16.
16. All right, our multiplier. What thing talked about its growth here? It doubles, so your multiplier is 2. And then finally, your x, which is time, 10 days. All right, so you have all the pieces, right? This equation all together would be 16,384 equals 16 times 2 to the 10. Now, I'm going to take away a piece at a time, and you have to prove to yourself that you could solve for it. For instance, here, 16 bacteria cells were collected and found to double in quantity each day. After 10 days, how many will there be? So, what did I take away? Y. So it's going to be y equals, and then you fill in the rest. And then this one will be put in your calculator, press enter. Another one will take away a. You got to solve for a. Another one will take away b. Another one will take away x. Once you solve for all 4, you do this one final problem, because I do want you to practice and show that you can do it if it was going down, if it was doing decay. And that's after that problem, come show me it, and I'll check all your work, and then I'll give you your homework if you've done it correctly. Okay? If you did not, you don't get your homework until you do it correctly.
Yay.
And then you get your homework.
And then you have to.
All right, so you were, on your homework, you were doing some exponential applications, finding different missing pieces. Typically, it was either y or your starting point, although there was one where you had to find your b. And then today we're going to talk about what if the other pieces are missing? What do you do then? So that's where we're going. But homework, what questions do we have on the homework? Two. All right, let's do number 2. All right, so here's your situation. Suppose that there are 12,000 bacteria in a colony. An antibiotic is introduced to kill the colony exponentially. 1 minute later, there are 9,960 bacteria left in the colony. So you need to write a function that can be used to predict the population. Okay, now, like we did in the notes yesterday, remember we had those 4 boxes, and you kind of had to figure out which of the boxes do I not have. That's what I need to find. That's what I need to solve for. That's what I need to write my full equation. So our boxes were, well, we wanted to know y, we wanted to know a, we wanted to know b, and we wanted to know x. So we could do y equals ab to the x, right? So let's think about it. Y was our final amount, right? So do we have that? Yeah, what is it? 9,960. A was our starting amount, 12,000. B is our multiplier. Guess we're going to be looking for that. And X is our time, 1. Now, today we're going to talk about what if X isn't 1, because X being 1 kind of makes this work for us today in this homework, but sometimes it won't be, and we'll talk about that today. All right, so then we have to plug in the pieces to find the missing piece. So we say, okay, well, we know y, 9,960, equals our A, 12,000. We don't know B, so I'll leave B and then raise it to the 1. Okay, well, anything raised to the 1 is just itself, so I really don't need that 1. So I'm going to erase it. Okay, well, now I want to find B. If 9,960 equals 12,000 times B, and I want to get B by itself, I should divide by 12,000. So these 12,000s cancel, and I know that my B equals, what is 9,960 divided by 12,000? I'm hearing different answers. 0.83. So my B is 0.83. Now, how can I sense check that that was a good B? Sense check.
Plug it in for 12,000 times 0.83.
Okay, so that's like check. But if I'm just sense checking, I'm looking at my B. What is my B? It's 0.83. Is that more than 1, less than 1? Yeah, this should be going down, right? Because we're killing the bacteria. Would 0.83 make things go down?
Yes.
Yeah. When you multiply by less than 1.
I'm just thinking about mine.
Right, so if you got 1 point something, you'd be like, oh, wait a minute, I did something wrong because this shouldn't be more than 1, right? It's just a sense check. Okay? All right, well, we didn't actually write the full equation yet. We want to write an equation that we could use to find any amount, right? No matter how many minutes went by. So now we write y equals 12,000 times our b, which we found out is 0.83, and we raise that to the x. Okay? So that's the equation that will work for no matter how many minutes went by. Okay, now it says, okay, how many bacteria will be in the colony 3 minutes after? Well, we have an equation. We can use it now, right? So we say, okay, now our x equals 3. So we just plug that in. And I say, okay, y equals 12,000 times 0.83 to the third. Put that into my calculator. And I get y equals 861 approximately bacteria. Right? Unless to give you that exact number or a decimal. Decimal, right? So that's why I said approximately, right? We're basically saying we know we can't have half a bacteria, so we'll round to a near number, and that'll be our approximate amount. Okay? Here, find p of 11. What does that mean in the context of this problem? Yeah, it's just this is asking in math notation the same question that was asked in B, right? But with a different number. It's asking the same thing. How many bacteria will remain after 11 minutes, right? So if you plug that in, y equals 12,000 times 0.83 to the 11, you would get approximately
1,545.
Yep, that's what I got. 1,545 bacteria. And what that means is P of 11 is asking you, well, or if you find P of 11, you find that after 11 minutes, there are 1,545 bacteria left. Okay? Any other questions on the front? On to the back. All right, on the back, we had a bunch of different little word problems here, finding different things. What would we like to talk about? Maggie, publishing, Manny, condos, Jack. Condos? Okay, hearing condos, I'm hearing Jack. Okay, condos in Fairview go up by a value of 5% each year in the Griffin family's condo. If the Griffin family condo is now worth $580,000, what will it be worth in 4 years? Okay, so I'm doing my little check here. Y, A, B, X, and I'm going to see what I got. All right, so 5%, what is that? Yeah, that's my rate of 0.05. And since this is going up, my B equals 1 plus my rate, and my B equals 1.05. Right? More than 1 makes things go up. So 1.05. All right, it's worth $580,000 right now. So what's that? In terms of, that's my A. That's my starting. 580,000. What will it be worth in 4 years? What's that? That's my X. So I'm looking for Y. Right? So that'll be nice because Y is always by itself. So I just need to plug this in. 580,000 times 1.05 to the fourth. Plug that in, and I get 704,993 and 63 cents. There you go. That's how much it'll be worth. Okay? Not bad. They're doing okay in the Griffin family.